Hello, I'm Ed Overstreet, and welcome to the Night Sky Imaging channel, YouTube channel. And tonight I am outside. I'm inside. I'm imaging outside remotely, and I'll be using two rigs tonight. I have a deep space wide field view of the Veil Nebula, and that's the NGC 6974, and also I have Jupiter right now in my crosshairs using an 8-inch SET with a 2.5 time Teleview PowerMate. So let's go outside and take a look. Okay, here we are with Jupiter, and I'm kind of waiting before I start imaging Jupiter, although I took a couple AVI files, but I'm going to wait until the great red spot, actually until one of the moons low starts tracking across Jupiter. And then following that, the red spot, big storm's going to be coming. So I'll show you what I'm talking about. Let's go over to WinJupos. This is the software called WinJupos, and this happens to be an image of Jupiter that I took last week, and not a real good one, not real sharp, but it is an image, and it has the great red spot right here. That's the storm we're talking about. But I'm going to go up and pull up this tool called the Ephemerades, and what this is, it's kind of a planning tool. But right now, if I click on real time, the planet low, LO, is situated right here, and it's going to move across Jupiter as it rotates around Jupiter. And I'm going to start imaging Jupiter in just a little bit. I'm going to advance Jupiter. This is real time. This is what's going on right now. And I'm going to move it up 10, 20, 30, 40. This is the shadow. The sun's coming from the right to left, and it's casting this shadow. So that's low, and that's the shadow of low on Jupiter. And we'll be able to see that when we process the image. And then right now, this great red spot's going to start coming. So that's at 3:33 Universal Time. So you subtract 4 hours. So at 11:33, the great red spot's going to start tracking. And I'm going to take probably 150 AVI files from 11:33 to, let's see, it's going to make the trip at 6:43, so almost 7, so it'll be about 3 o'clock. So from 11:30 to about 2:45, the great red spot's going to move across Jupiter, and I'm going to be taking a 2-minute video, trying to get as many frames as I can taken in a 2-minute time. Because of rotation, that's my limit. And I'm going to take a 10-minute or 10-second interval between these AVI files, so I could calculate how many files I'll end up with, but I'm figuring probably somewhere around 150 to 200 AVI files. So and then I'll process those into a GIF, hopefully, and kind of have a movie of Jupiter with the rotation of Jupiter. It rotates about once every 9 hours, so the Earth takes 24 hours to make a rotation, and Jupiter's considerably quicker than that. And then I also have another telescope in the works. Let me bring up our outside surveillance camera. And you can see that we've got this larger Smith Cassegrain, that's what's currently imaging Jupiter. And then this wide field is on NGC 6974, which is the Western Veil Nebula. And this is my third night imaging the veil, and I'm trying to accumulate enough data to make an image. And I actually took what I had this morning early just to see if there was anything worth working with, and I'll bring up that I'll bring that up on PixInsight. Let me load the project, and we want to go to the veil. There's the project, and we'll open that up. All right. So far, I've got some HA, and it looks like this. I stacked the hydrogen alpha that I had, and it's coming along pretty nice. I don't have much sulfur 2. I only took 11. I only had a chance to take 11 images that were 5 minutes each, so about an hour's worth of S2. And I think there's 20 images of O3 oxygen, and those are all the images will be 5 minutes long. So I've got a little more oxygen that's showing up. So far this is what we've got, and it actually produces a pretty decent image. In fact, I'll go ahead and stack. We'll just use the we'll use pixel math and do the show color. Let me bring hydrogen alpha out, and we'll stretch that. It's going to be real green right now, but this is the color image. It's going to be real green because hydrogen alpha has been mapped to the green channel. The green channel has 80% hydrogen alpha and 20% sulfur 2. So that's the equation I use to create my Hubble palette. And when I finally remove the, I'll remove some of the green. Not now. It doesn't really mean anything right now. That's all going to be, all those colors will ultimately be changing, but the image is linear, and when we color balance it and do all the other stretching, denoise, and make those tweaks to it, the real colors will start revealing themselves. Okay, but that's what we're kind of working on, and let's go over there and look at what's happening. So let's see, that's the Jupiter, and here we go. So this is the veil, and the way I've got it set up right now, I'm taking sulfur 2, and I have so far 22 images that are 300 seconds or 5 minutes. I hope to get 30 in all, and I hope to get 30 in all of oxygen 3, and another 20 images for 50 of hydrogen alpha. It's pretty rich in hydrogen alpha, so I want to get as much of that data as I can. And this is what one image sort of looks like in sulfur 2. I'll stretch that a little bit, and you can see the fake data. I'm not sure you can on YouTube or on Facebook, but this is the really faint data that's coming in one image at a time. And but when you stack those pictures one on top of each other in post-processing, they look pretty sweet. And you had a chance to see that in PixInsight, the software where I stacked what I had for an image. So we'll go back and take a look at our data. We're currently looking at 3 hours and 7 minutes of imaging time left, and I may, seeing how the clouds go, I may go ahead and bump up the imaging a little more. Sorry, I didn't realize you didn't have this screen. But again, I may add some more sulfur, oxygen, and hydrogen because I have 3 hours of imaging time left, and it's still early. So at 10, 11, 12, 1, 2, 3, 4, 5, I may add another 3 hours of imaging. So with that, we might add another 20 more pictures divided up over S203 and HA. Let's go back to Jupiter, and let's take a look at Jupiter. It looks like the scene is pretty decent. I did go ahead and process one of these, and I'll show you how I do that. I'm going to go to a software program called Castrator, and I'm going to open a file, and let's just open up this one here, and I'm going to click on color because it's a color camera, and I'm going to process it. And what this is going to do, it's going to go through all the 4,000 or 5,000 frames, and it's going to stabilize them and align them. It's going to make it easier for AutoStacker to do the stacking. And it's about done. All these take a few minutes to process, but you're compiling a lot of data in order to get an image. Okay, we can close that. Then we're going to bring up AutoStacker, and we're going to open up this file, and here it is. And we're going to kind of scrub through this and look and see if we've got one sharper than that. Let's just go with that. I'm going to analyze it. It's going to give me a quality graph about here, and it's going to tell me what percentage of my pictures are above the 50% margin and what are below. And so not quite half of my images are better than 50% or the 50% margin. So what I'm going to do is I'm going to go ahead and process 60% of them, and I have 60% here. I might go ahead and put in 40% and process 40% as well, because not quite that may be a better stack. But I need to place some alignment points first, so I keep close to the edge and replace checked, and I'm going to place a grid. I'm going to use 104 as the size of these boxes. That's 104 pixels. And I'll add a few more, and I'm going to stack it. Now what it's doing, it's going through each frame, and it's picking the 60% of the best frames and then stacking those together. It's also, while it's doing that, it's going to pick 40% of the best frames. So I'm going to have two folders, one with 60% and one with 40%. You're better off having fewer frames but having better quality than having a lot of frames, some of which aren't good. And that's what will drive you to create maybe even a 30% stack. So right now it's doing its thing. It's actually stacking them. It's gone through putting all of them into a reachable cache and buffering. It's gone and found my reference frame to compare the rest of the pictures to, and then it's aligning them. And once they get them lined up, then they're going to stack them and put all the data together in one image. It'll be a TIFF file. It mapped the image color-wise and combined, so it's actually been done. It's now creating the 40% bucket. It created the 60% bucket first, and that's the folder to put the pictures in. When I start imaging Jupiter, as the red spot starts to show itself, then I plan to I plan to probably create a 70%, 50%, and 30% folder, and I'll batch process a lot of them. Okay, we can close out. We're done here, and let's bring up Registex. Registex is where we're going to develop the picture, and we're going to go find it, and it is right there, and it says I have a loading problem, and I'll fix that right there. I don't want to stretch it. Let's show the full picture, and so that's what we're looking at. Let's first turn it to auto balance, not turn it to anything, so we have really brought the color out in it. I'm going to run a histogram, and I'm going to stretch it just slightly, brighten it up a bit, and then I'm going to flip it to about 125 degrees. I like it to I like north to be north, and I like it to be at a slight angle, and 125 ought to be close. There you go. This is the north part of this is North Jupiter and North Pole, and here's the South Pole. And now we want to add some wavelets, which will give the appearance of sharpening the image, and it'll look more like Jupiter. There we go. So there is a sharpen a little bit here on the wavelet sliders, and probably no more than that, because I'm going to have to apply some noise reduction. But there's the gas giant. We're going to do all, which is going to apply the effect that we've made. All these different functions will now be applied to the entire planet, and we're going to save it, and we're going to add the extension REG for Registex, so I'll know I have processed this. Okay, I'm still going to wait before I start imaging Jupiter until the great red spot. That's going to be another couple hours, and the seeing conditions ought to be better, but more important, Jupiter's going to be higher in the sky, and I'll have a much more defined Jupiter to image. It'll be sharper, there'll be a lot more clarity. There should be, unless the skies turn, and that can always happen, as we know. So let's go back to our other kit, which is, by the way, I want to make sure I've got my time right for this. Let's go back to real time, and so right now it's 9:50, so this will be 10 o'clock, 10 o'clock, 10:10, 10:20, 10:30, 10:40, 11, 11:10, 11:20, 11:30, 40, 50, 60. So about 11:30, got the shading on, but about 11:30, Jupiter is going to be visible to me. This shading kind of prevents, I mean, it's going to be visible, but the great red spot's going to become visible to me. That's when I'll start imaging. So about 11:49, 11:50 is when it's going to happen. So right before midnight, you guys will probably be tucked in. I'll just be getting started on this gas giant. So, okie dokie. Now back over to the other kit. And this is this is Sequence Generator Pro. This is my acquisition software, and the sequence I have set up is these are my light frames. The filter that I'm using are right now, it's a sulfur 2 filter, and it's in front of my camera sensor, and when it's done, the O3 will switch automatically into place. It's on in a filter wheel in front of the camera. It'll rotate automatically, and then when it's done, hydrogen alpha filter will be centered inside the filter wheel for the camera, and we'll take the balance of our images at night. Then what I'm going to do, I'm going to make sure that I have this checked here, park telescope, because I'm going to have this set up where I'll probably image close to all night. I'm going to add some more. I'm going to calculate how many pictures can I take that are 5 minutes long that will carry this through, say, 3:30, maybe 4 o'clock. And once I know how many pictures I can take, I'll change the number here, and I'll factor in the time it takes to refocus between filters and to refocus every 2-degree temperature change, because that's what I elect to do. And then also dithering often requires that the mount have settling time so that it can kind of settle down before it starts imaging again after it's dithered. Dithering is a command that tells the telescope to move very slightly, a pixel or two between pictures. And the reason that you want to do that is that the noise that is predictable in the pictures can be identified in post-processing, and it can be subtracted out. So that's kind of a requirement to do in doing deep space imaging, that you dither between images. And we'll take another look at let's do a high stretch, and there's our data, that sulfur 2 data that we're getting. There's not as much sulfur 2 as there is hydrogen. There's more oxygen than there is sulfur 2. Sulfur 2 is the weak gas that we're going to be imaging. So in theory, I should be maybe taking a slightly longer exposure, and maybe taking a few more sulfur 2s in order to make its presence known, but I won't. Okay, let's bring our sequencer back up. And that's it, folks. You now know what I'm doing tonight, and I will show you the results of our images, and when I'm done, and let me see if I think I finished, I'm pretty sure I finished the, I'm not positive, let me go back. Let's go back to September, M31. It didn't turn out real good. I'll open it up. There's M21. That's I did finish it, but I'm not real happy with it. That's the Andromeda galaxy, and it's about 1,500 light years from Earth, and it's our closest galaxy. It's in our local group. I don't think we stand much chance of ever getting there, but in 4 billion years it's going to collide with our Milky Way galaxy, and also in 4 billion years our sun's going to flame out. So that's going to be an exciting time for if you think we have problems on Earth now, advance the clock 4 billion years when Andromeda is merging with the Milky Way and our sun is about to flame out, and I would say our priorities will definitely be changing. With that being said, I guess it's time to bid everybody a good night, and I'll be up for a good while playing, and I hope everybody has a great Sunday or a great tomorrow, whatever that is when you watch this, and a good rest of the week. Make sure that you find a few minutes to say something nice to somebody, And if you do, I know this, you're going to really feel better about it yourself, and you're going to make somebody else feel good too. So have a great night, guys.